Good evening. Well, it's great to see such a fantastic turnout. I'd like to welcome everyone here tonight. My name is Christy Ballier. I'm an assistant professor of architecture and the chair of this semester's Knowlton School Baumer lecture series entitled Twist. A twist tactically combines and intertwines design methods, disparate fields, and physical matter. It is dynamic and implies fitness. The lecture series includes innovators that demand an expanded reach. They maintain a stance within one discipline with a deliberate movement and connection toward another. Collectively, they design visual languages, reveal untold narratives, embellish into fashion, require close readings, explore new ancients, and reshape environments. Twist is a series with a few unexpected turns. Our lecture tonight exemplifies this innovative twist. It is my pleasure to kick off this series by introducing KSeries with the lecture entitled Graph. Casey is an artist that explores, expands, and invents the edges of his field through the contemporary lens of software. He is a professor of design media arts at UCLA, and he holds a master's degree from MIT as well as a bachelor's degree from DAP at the University of Cincinnati. With Ben Fry, he initiated processing in 2001. Processing is an open source programming language and environment for the visual arts. In short, Casey writes software to explore conditional systems of art while simultaneously developing methods of teaching, creating, and viewing new media. He designs the code and builds enthusiasm around software development and its generative potential. Through defining emergent networks and layered instructions, he explores software as a medium. He is an expert of the digital medium. He also collaborates extensively with artists, architects, musicians, and computer scientists. He has designed books with titles better pronounced by computers, handbooks for visual designers, site-specific projects such as murals that animate the surfaces of contemporary architecture, Frank Gehry specifically, and makes musical stage sets for the Yaysayers with Aranda Lash. Casey's software, prints, and installations have been featured in over 100 solo and group exhibitions at museums and galleries in the United States, Europe, and Asia. And in the midst of all of this production, Casey has generously agreed to lead a workshop that kicked off this afternoon on code and form. The workshop and lecture are co-sponsored by the Department of Design and have an equal part architecture and design students. The final results of this workshop will be displayed in the jury space this coming Friday afternoon. Please join us also following this lecture tonight for a reception in the main space. And please help me welcome KSeries.
Thank you, Christy. So I'm really happy to be here this evening and to see so many people in the room. That's wonderful. It's been a few months since I've been out of my studio. We're still on the quarter system at UCLA, so I'm kind of reeling from all the academic energy today. I think with that comes a lot of enthusiasm, having been working and now sharing. And I'm really enthusiastic to share my work and share my ideas over the next 45 minutes or so. I think in order to make some sense of the talk, I might let you know a few things. One is that I have these 4 different practices or interrelated practices that I'm going to weave together this evening. One is that I work in my studio, I do research, I create new visual experiences. Another is I teach studio classes at UCLA. A third is that I'm the co-founder of Processing. Processing is an open source, free, fully online, community-focused programming language and environment with the goals of adding or or building a new culture of programming, one that's not rooted in the engineering and science areas, but more rooted in the visual arts. And then fourth, I've been writing books over the years in order to support the work of processing and my teaching. And so we're going to look a little bit at all of those things and spend time looking at my work, and then also to end by looking at a range of work across the fields. So the first thing I want to do is to have a bit of a screening to give you a chance to experience the work. All of my work is generative, it runs in real time, and images don't capture its essence. It's about choreography, motion, and time. And it's really impossible to have that experience looking at documentation of the work or looking at the work online. So I'm going to show you 4 pieces of software and give you a chance to have that experience, and I'll be a little bit quiet while you look. It requires a little bit of concentration and patience, but I hope it's worthwhile. Here's the first piece. It's from 2001. I'll do a little bit of narration as if I'm describing on the Nature Channel something found in the wild. This piece is, well, each line is a synthetic neural system that's been heavily abstracted. And it's based on the work of Valentino Breitenberg, who's a neuroanatomist. And in this book called Vehicles, which he wrote in the early 1980s, he abstracted his career of working and studying neural systems into this series of small mechanisms, these small vehicles. And each one of these lines is the path that one vehicle takes as it navigates this environment. And sort of the stimuli in the environment is not visible, but it's revealed through the paths that are taken. The next piece is generically titled Network B. It's from 2005, or maybe 9. We'll see when it closes. I've worked a lot with synthetic networks over the last decade or so. With the idea of the exploration is that the grid was the dominant form of the 20th century. The grid in computer chips, in urban structures, et cetera, I think was a large definer of the culture that we were creating, with the idea that in the 21st century, the network is the form. And unlike a data visualization, these networks are entirely synthesized, or they're not synthesized, they're synthetic. The data is being created through a set of behaviors and instructions, but it's being created as the software runs, rather than visualizing a pre-existing data set. This piece is a hybrid of what the software wants to do, what these individual elements do in the program that I ask them to follow, or really within computer code I force them to follow. And it's also a mix of drawing. So they're put within the plane based on marks that I made with my hand. And those marks are being played back. But this piece can also be performed live and has been performed live as an audiovisual experience as well. The next piece, that was 2009, is Network D from 2012. And then I think although the present form that we're looking at in growth doesn't really reveal this source. This was made for a show that I built about 2 years ago called Century, where I looked at different movements and ideas in 20th century art, and I brought them forward to my time. And the origin of this piece is Mondrian's Broadway Boogie Woogie. And I started thinking about that music, that very dynamic music, which I think at the time was radical and was full of life and vitality. And I started thinking about the music that I was listening to at the tail end of the 20th century. And I worked with this network structure that again is being generated, and then started building on top of that this other structure that I thought was really reminiscent of the music and sort of the experiences that I was having. So in relation to and opposition to the original source painting. A lot of my work goes through cycles. It draws and erases continuously. So the work typically has a begin but never has an end. So then another cycle begins. The last of this first set of works I want to share with you is essentially different from that. And this work grows out of my recent explorations in working with mass media, trying to explore the media that, in my opinion, most defines our culture. And this piece uses television signals, captured over the air with old-fashioned rabbit ears, kind of the kinds of signals that are in the ether and always around us. And then it amplifies parts of that signal while obscuring other parts. And so there's two rhythms happening here. One is the rhythms in the original source material, the way the camera moves, the way edits and cuts happen, and then the other is the way that material is being sampled and then recut and re-edited by the software in real time. We'll look more at the ideas behind these four pieces, with the exception of the first, throughout the presentation. So in addition to working with software, as Christy introduced, I do things with the software. I've been working with drawing always, and then making prints and imagery from the software is something that's always been a part of my practice. This is an image that has been further worked from the first piece of software we looked at with the white lines on the black field. And this is another print from a related series. And then I also, within the last few years, have started to work at different scales. So this is at the Art Institute of Chicago. And again, it's printed work, but it's at more of an architectural scale. All right, that's what I do. What I want to talk about now is some ideas behind that work. We have a few different sort of generalizations about software. First is histories. This is a diagram from my notebook from earlier in the year. And what you see here is essentially charting visual media over a long period of time. We have painting, which originally starts with frescoes and other kinds of painting moving forward, the advent of printing, how that affected visual media, and then photography and cinema, after that video, and now software. The idea here is that while software is relatively new, It has a 50-year history within the visual arts, but we still know relatively little about teaching with it, thinking about it, using it as a part of our traditional visual practices. This is a technical document from 1962. This is just evidence to show that this kind of work has been around for a very long time, 52 years with this document, by A. Michael Knoll, who at that time was at Bell Labs, which was a hotbed of innovation in the visual arts related to computation at that time. This is some Fortran code, which this technical paper is about, and this is the result of that Fortran code. The history of this field has a lot of different terminology over the years. Some of the original terms were computer graphics, computer art. At Boeing, they were doing some extraordinary work in 3D modeling, also at SOM in Chicago, some early pioneering work. But of course, the history of this field isn't purely technical. It's conceptual, too. It's about the ideas. This is a catalog from a show in 1970, curated by Jack Burnham. It was at the Jewish Museum in New York. The reason I really appreciate this show is because it combined architects, technologists, and conceptual artists together without hierarchy. So the image you see on the front here is from Nicholas Negroponte's Architecture Machine Group. Also included in the show are conceptual artists like Hans Hacke. And outside of that, conceptual art, minimal art, systems art, process art, etc., is another of the sort of foundational ideas for the kinds of work that I'm doing today and we're working at across different fields working with computation. A core idea is this idea of the open work, and this is the name of an Umberto Eco essay. And in that essay, he uses the work of Alexander Calder as an example. So in working with code and computation, instead of building a static form, a stable, we make things which are relationships among parts, like a mobile. And so here you can see the different pieces, you can see the physical connections and relationships. So Calder makes a work, which is really a system, and then from that system, multiple kinds of forms can emerge. These are images of the Calder sculpture taken in motion by Herbert Matter in 1936. So for me, this image demonstrates building a system and then being able to view it with different parameters from multiple angles as a way of opening the work to multiple instantiations. This next idea with software, this idea of generating and editing, I think is really akin to how photographers often work. You take a roll or 10 rolls of film, or you put 1,000 photos on an SD card, and then you sort through that information. There's a separate process of making and editing. So these are some examples from a piece we'll look at a little bit later called the Coronagraph, just to show sort of what are some of the results from the software within a range. And from here, modifications are made, parameters are tuned, that then brings the piece to the next level. So you can, in each of these images, you can see what's the same and what's different. And these are examples of generating different form before making some decisions to go to the next. The next note or idea is this idea of materials. I don't think it's a stretch. I think it's really appropriate to talk about different programming languages as different materials. We all know that different materials have different affordances. I'm working with cardboard, I'm working with plaster, I'm working with steel. Programming languages have a strong analog to that. But also, they set up a mental view or a mental model that we work within. I'm working in AutoCAD, I'm working in Rhino, I'm working in Maya. Each one of those programs sort of sets a world that we start to think within. So these are two examples of programming languages. At the top we have BASIC, below we have Logo. And these are both programs that draw a triangle. So the program at the top assumes some knowledge. It assumes you know about Cartesian coordinates. It assumes you have this understanding of plotting. The program at the bottom assumes you know three things: that you know your right from your left, that you know how to go forward, and that you do have to know about degrees or angles, which you can kind of embody. The top program is objective. We're looking down at something and putting things within a frame. The lower program is embodied. We move forward, we turn, we move forward again. So two ways of making the exact same shape using different conceptual models supported by different programming languages. The two basic families of programming languages are text-based programming languages, which we see an example of at the top. This is how you draw a circle in processing. and visual programming language. This is kind of a notation that I invented, but it's very similar to these flow-based programming languages, like Grasshopper, for example, which have a large analog in synthesizers and patch cords. There are two different ways of thinking about the same thing. One where you're connecting pieces, another where you're writing, which is really very analogous to writing text. This idea of notation and writing, I think there's an interesting analog between being a composer, being an architect, and writing software, which is what I do. And that's that your final work is often a form of notation. If you're an architect, the final work might be a plan and section. If you're a composer, the final work might be a score. If you have a practice like mine, the final work is a computer program. And all of those, that final form becomes enacted by another party. So I'm going to take a slight digression to make a larger point. This is a zoomed out view from the image we were looking at the beginning while Christy was giving the introduction. And this is an image of a Commodore 64 output on a CRT machine running this one line of basic code that you see there. So this is a page from the Commodore 64 user manual from 1982. And this is the code you see in that black box up at the top. This is an image of a Commodore 64. What was special about this machine are that it had a graphical language called PETSCII. You can see the two keys we're interested in are the N and the M key, and we're interested in those diagonal lines. So this program flips a coin, and it basically says flip a coin. If your heads, draw a diagonal line facing one way. If it's tails, draw a diagonal line facing the other way. And so in BASIC, you start a program with a number usually. So we're going to say 10 print, and then we're going to not print to a printer, but we're going to print a character to the screen. And the thing about this diagram is that the left line is character 205, and the right line is character 206. So we're going to say we're going to split the difference, and then add a random number between 0 and 1. Uh-oh. Haha. I have to reboot the Commodore 64 because somehow I changed it so we're not writing letters anymore. So bear with me for 1 minute. There we go. All right. Oh, caps lock. All right. I'm giving you a lot of confidence in my technical sophistication. All right. There we have it. So we hit run, and you can see what happens. So at the rate at which the Commodore 64 runs, which is what we're seeing here, we flip the coin, we get a left or right line. But what happens here is that this other thing emerges, this maze-like form, which isn't really a part of the program, it's more a part of the platform and an artifact of how it operates. So where this is going, hit escape to stop the program, is that for a program like that, we of course have different ways we can specify, different kinds of notation. This is a piece of text I wrote a couple years ago, layers of original and appropriated instructions. So we have our first layer, which is make a grid or find a grid, do one thing or one other thing inside each unit. This describes a few hundred pieces of art made in the last 100 years. It's very general in terms of what it describes. At the next layer, we'll go one step more into detail. And, that's a kind of program that I think everyone in this room could write. It's written in English, which there's an assumption that we all speak that language in the room. And it doesn't have any jargon, notation, any kind of special characters. The next one, I think, too. Draw a uniform grid of 200 by 200 squares. Within 1 square meter, open a telephone directory and read the numbers in order. For each square starting in the upper left corner, fill with blue paint if the number's even, and fill with red paint if it's odd. So this is actually an important work of 20th century art by Francois Morellet. I don't know if it's in the collection at the Pompidou, but it's recently been exhibited there. If we go one level deeper, Stratum 1.2 is the Commodore 64 instruction written in English. And stratum 121, which we see here, is our Commodore 64 program. And then sort of the larger point here is that now we've gotten to a specification where I can understand this program because I know how to read Commodore 64 programs. It's likely many people in the room cannot, but it's essentially doing exactly the same thing as that piece of code above, where the program becomes so specified that it's specific to one platform, the Commodore 64. And then what we see below, stratum 1.2.2, is exactly the same as the two above, but written for a different platform. This is for the processing programming language. So it's a precisely identical system, but in a different notation for a different platform, a different machine. So one of the many ideas here is that programming languages are simply just precise ways of defining instructions, and that defining instructions is something we're all familiar with doing within the design field, design disciplines. All right, I think the last idea about software is sketching. And this is a twofold idea. First of all, I still am a strong believer that sketching starts like this. And I think sketching is important for two reasons. One, it gets fuzzy and vague ideas out of our heads and into a notation where they become more concrete. And secondly, they put ideas into a notation where other people have access to those ideas as well. And I guess there's three. The third thing about sketching is it allows you to work extremely quickly. If I were to open up processing and start writing code to produce some of these images, it might take me a day or half a day. But if I open up my sketchbook and start drawing and making notations, this might take 2 minutes or 5 minutes. So you start working roughly and quickly, and then you gradually refine and put things into more structured format. These are sketches for something I'm going to show you in a minute, and other random sketches on the other side that aren't particularly good. But the sketches on the left are what's of importance right now. So I want to show you the second idea then, on top of that, is that there's this notion of sketching in real materials or sketching in code. If you're a painter, you might sketch on paper. If you're an architect, you might sketch with cardboard, et cetera, et cetera. When you're making things that are software, you oftentimes start by sketching with code. And I want to show you an example of what sketching with code means. Here's the code. And then here's what the code does. What's built in here is this idea that the circles have their own space, and when they overlap with one another, they move away in order to have that unique space. It's a really simple idea. Took a couple hours to program. Once that work was done, I could explore it in a different way, in a visual way, rather than strictly thinking about it as a system. All right, the next example is here, where I've added something. I've added the ability to move on a straight line with the behavior that when you overlap with another circle, you rotate and change your direction. So it puts it into perpetual motion, and that yellow dot just shows you the direction of motion. So it took a long time to write that first program, but now things are happening quickly. Things are happening on like 5-minute intervals, for example. The next sketch, as a part of exploring, this has all been kind of compacted and reduced to the essence, but there were a lot of other programs in between. We've now added something and removed something. We've removed the circumference of the circle, but we've added a line when the two circles overlap. So when lines touch or kiss, we draw a line between their center points. And that then becomes the foundation for this piece, where now the only thing that's left are the lines that are drawn between the two pieces. And we can start it up in different configurations, from a line in the center, from a line at the top and bottom, at an even distribution, and around a circle. And once we have that system built, we can also look at it visually in different ways. So for example, here, we're no longer looking at the lines in between the elements, but we're looking at that little yellow dot before, which is now a black dot, and the circumference of the circles are being drawn in white, so they're erasing at the same time other things are writing. So again, we can look at it in the same series of configurations. So different ways of looking or different perspectives on that same system. So that's an example of sketching, and then that sketching over time led to a more, I would say, clearly defined system, which we can see here. So we have form 1, which is a circle, behavior 1, which is move in a straight line. So these behaviors which were in code notation are now being put into a more straightforward general notation. Constrain to surface. Behavior 3, change direction while touching another element. Behavior 4, move away from an overlapping element. And then this becomes element 1, where we combine this form, the circle, with these 4 behaviors. And this is the result. If we sort of reveal some notation, you can see better what the behavior is. This is the equivalent of that yellow dot before, showing the direction. Here we're showing the rotation when it happens. Here, the moving away from the other elements. And then, again, this is the summary of those behaviors. Align with oh, this is a different one. This is element 5. That was element 1. So here we start with align, and these are our behaviors. Move in a straight line, enter from the opposite edge after moving off the surface, orient toward the direction of an element that's touching, and deviate from the current direction. So this is the result of that. So these lines start off with an even distribution, and then over time they start to group together and form these clusters as they start to assume some of the angles of the lines that they overlap with. So one of the ideas, this was inspired by the periodic table of the elements and how things work at the most fundamental level with material and elements, and trying to build out with the most simple Platonic geometry and these simple behaviors the maximum number of possibilities and options. So this work is often exhibited like this, where you have the diagram and the instructions on the sides, and then the result on the other side. So we're going to look quickly at process 18. So this is element 5 that we were looking at before. And what you don't see here are the written instructions flanking each side, the diagram view and the aggregate view. And you can see there are 2 windows into the same thing. In one, we're drawing on top of the diagram and continuing that. We're not erasing. And the other, we're simply just drawing the diagram of the lines. And the instruction here is that when 2 lines overlap, you connect their endpoints with a quadrilateral. And the longer they overlap, the more opacity you give to that shape. So that's the beginning of a kind of exploration. And then that was process 18. What we're going to look at now is process 18 software 6. And I want to give you a minute to view this. So again, with this work, it does have a beginning, but not necessarily an end. After a while, it reaches a density and a saturation, and then sort of maintains a balance as it writes and erases. This one's particularly slow. It takes a while to get to that density. And for time, this work is really meant to be viewed over a long period of time. It's more ambient than cinematic, which is the structure we have in the room right now. And it's meant to be viewed from day to day, rather than in short little bursts. All right, for time I'm going to kill it and go to the next. From that software, a lot of other things are created and explored. These are some close-ups or details of printed images which come from process 14. These are some objects that were created from process 18, which is what we were just looking at, the 2 previous pieces of software. This is an installation from process 4. And each one of these disks is a generative animated system as well. An installation from process 7. An installation from process 11. And all of these processes work in the same way. Take either a circle or a line, apply a few behaviors, and then build a surface on top of that. This is process 16, software 3, installed in Burlington. This is process 18 at the Whitney Museum, kind of while they're setting up for their annual gala. This is kind of a hybrid of process 4 and process 7, which is related one of the second piece of software I showed you, Network B, and this is a performance where I was live on stage drawing, sort of in relationship to what was happening in the music. The music here is Steve Wright's Music for 18 Musicians. Music has a very strong influence on my work, particularly kind of American minimalist contemporary music. And this is a print from, again, from process 18, a variation of process 18. And then the compendium was wrapped up a few years ago with this set of 15 images, which became a box of prints, which documented process 4 through 18. And here you can just see the prints laid out in my studio, kind of looking at, expecting everything before packaging everything up. So the next project is the Coronagraph, and this is a collaboration with Tal Rosner. And for the process work, it's very organic in nature. I don't really know where I'm going with it. I write some code that then becomes a starting point for another piece of code. With Coronagraph, it was a different situation, largely as a part of the collaboration. This is an image of the piece installed. This is the New World Center, which is in South Beach in Miami. It's a project by Gary Partners. If you don't know this project, it's a cousin of the Disney Concert Hall in Los Angeles. It's inside out. You can see it's a box with a curtain wall, but all of the forms that are sort of the signature forms of the Disney Concert Hall are on the interior of the building, which you can see in that lit space. And it's the same acoustic engineer, but it's a much smaller hall. Here's the building from a larger distance, Miami. It's in the South Beach area, and so there's a lot of these Art Deco elements. And this project was largely about making a synthesis between architecture and about music, what was happening inside the building, and working with rhythm and pattern and composition and time. Here's a view of the building, more of a snapshot, so you can get a sense of the area around it. This is a projection tower with the 4 projectors that create the image on the surface. And this is a short video that shows what the motion of the project is like. So this is what's projected onto the facade of the building. All of the imagery is taken from the building itself during construction or the neighborhood around it, so it's extremely site-specific. And again, it's more of an ambient piece, and it's built on this idea of the metronome or the clock, where every second there's a little bit of energy put into the system. On the minute, there's more energy put into the system. And then on the hour, there's a transition where it goes from one composition, for example, each of these is a composition, to another, and it transitions through a number on the way through. Here's another one of the compositions. So there's over 300 different hour-long pieces for the building. And again, each one is on the building for an hour at a time and then transitions into another after that. You can see the forms of the building during construction, of the neighborhood around. And the idea is to have this experience both for visitors and also for locals, of having this continuously changing, shifting experience as a part of the building, very site-specific and related to the public park in front. So, unlike some of the other work where there's a really organic process in software, we worked on this project for over a year, longer than that, before we even wrote the first line of code. So we defined the whole thing and then built it after in software. This is an image on my studio of over 1,000 different composition ideas that we had. And what I'm going to share with you now, and then from there, we built all of these contact sheets and started doing an editing process. So you can get a sense of here of the visual variation that's encompassed by the piece. And what I'm going to share with you now, I don't think has been shared with an audience before, but it's the presentation that we made to Michael Tilson Thomas, who's the conductor of the New World Symphony, and also to Frank Gehry to get his stamp and endorsement on the project before we started actually implementing it. And so this was all created not with code, but more in a manual way. And what you see are, this is the building at the very beginning. And we shot the building through its entire construction process and started building the compositions for the piece around the photography from the beginning to the end. And the point of doing this was an exploration, like a visual exploration between Tal and myself, trying to find this language, this common language between us that will become the language for the project. And again, this idea of marrying what we're passionate about music, with the architecture of the building and the local environment. Exploring and finding a form language that then was implemented later in code. And it's the procedural animation, or taking these and putting them into motion with software, that allows the piece to run continuously, always changing, always a variation. You can see here the building starting to be more complete and how that's informing the compositions that are being built and constructed. A lot of this steel was covered in the final building, and we were really interested in exploring these lost forms and, in a way, excavating them and putting them back onto the surface of the building. This is the bridge to the parking garage from the building to the garage next door, which was not designed by Gary Partners. This is the projection wall, kind of midway, while it's still being surfaced. And here we see these two images on top of one another of the wall before it was covered. Here's some interior stairwells, some of the sites around the construction, and what could we do with that. Views from the building of the ocean, South Beach. So from these composition studies, we then focused in on a set few and developed this technique of building compositions like this by taking an image, cutting one piece from that, and then repeating that image in time to produce the larger compositions. And we invented our own data format that allowed us to define the compositions programmatically. We broke everything down into 12 different systems to allow different kinds of motion and rhythm over time. And then it's really by tuning these numbers that allows each composition to work. All right, next project is ultra concentrated. And this is related to that last piece of software that's built from the television signals that we looked at. So this is installed at the Bitforms Gallery last fall, and that object you see in the front is a collaboration with another collaboration with Aranda Lash. This piece in particular is a diptych, and here you can see with some more clarity what it looks like in photograph. Another image, and what I want to show you now is the sketches that led to that piece. The first one we're going to look at, so these are in a way are the technical infrastructure behind that and the code that enables that work to happen. So what we're doing now is looking at a photograph, but we're only looking at it one pixel at a time. So we're isolating the color of an individual pixel and then making that the full image. So how do you load an image? How do you grab a color from that image and then present that on screen? That's the sketch. That's the bit of technique that was needed in order to make the piece. The next sketch, so these I write lots of little sketches like this as a part of figuring out how to make it work. This one will resonate with the wonderful students in the workshop, and it's working with repetition and parallel lines, where here instead of taking an individual pixel, we're taking a row of pixels and then stretching that to fill the screen. This is a technique called slit scanning. And then from that's really everything that was needed to know in order to produce the piece that we were looking at earlier. Working with video is just like working with photography, or similar to working with photography, only the image is updated 30 frames a second or 24 frames a second. So I'll pause now for a moment and be frank with you as my dear audience. Sometimes when I give talks, I'm very conversational, like tonight. And sometimes I just burn through projects as fast as I can. Because it's been more of a conversational presentation, we're scheduled to go over the amount of time. I usually don't like to talk for more than 45 minutes. So I'm just going to tweak the pace a little bit because I really want to show you a set number of things. These are some images that are prints constructed from that software, ultra concentrated. And these are part of a series called The Control Room. The idea is that we always see these image grids in the television studio, in the back room of surveillance cameras, and putting these augmented or adjusted images together in that same kind of format or structure. Here's an enlargement of one of those. And then this piece is related to that. The circular form for me relates to telescope and the microscope, and also silicon wafers and how those are etched. The piece itself is anodized aluminum, and then that anodization is etched off to create the imagery on it. And it's essentially this kind of imagery that's been treated as a data set and pulled apart and then viewed from a specific angle and then in 2 dimensions etched onto the surface. This piece, KSeries Slabs, Los Angeles, is a nod to Rainer Bantham, the eminent architectural critic. In 1972, he made a film called Rainer Bantham Loves Los Angeles. So this is my ode to that film. It's an extraordinary film if you've never seen it. It's a really different Los Angeles in 1972 than the Los Angeles of today. And this is a commission for the Textile Room, which is a project built by North Sails, which is the industrial partner. They build sails for high-end sailing, and Patterns, which is an architecture studio in Los Angeles. And the commission was to build a projection piece for the structure. Here you can see the structure a little bit better. You can see that some panels have projections, some not. The whole thing is made out of steel with a skin of carbon fiber and aramid. And we're projecting from the interior onto these panels, and then the whole piece sort of is illuminated with lights moving through the surface to the exterior. Here is a video of this piece. And Marcelo walks into the video in a moment so you can see the scale. And this was at the Museum of Contemporary Art in Los Angeles last summer. And all of the content on the surface, kind of like the Rainer Bantham film, comes from the city of Los Angeles. And also like another film, Tom Anderson's Los Angeles Plays Itself, which is a documentary all about how Los Angeles, over the decades, has been portrayed in Hollywood films. We take these 2 primary elements of the city, the freeway systems and the infrastructure, mixed with the Hollywood system, and how one is depicted through the other, and then isolated and then projected onto the surface of this pavilion. Right next to this pavilion is a pavilion designed by Elena Manfredini, who will be here later in the year. So she'll probably show that piece. So they were very different pieces in dialogue with each other in the space. This is the source material. I think this is from Speed. We have Die Hard, The Big Lebowski, but only clips that really show the infrastructure of Los Angeles and how it can be depicted. And we go back and forth from day to evening to sunset to night, and everything's slowed down to quarter speed and without sound. In some way that augments and slows down the viewing so details can really be focused on. I think, as you all know, in many ways Los Angeles is an entire dystopia. It's a lot of contradictions, but in this piece, it's an earnest dedication and ode to what the city is. So you can get a sense of what the source material is. This is the actual structure designed by Patterns. This was the tricky part. So this project, unlike some others, where there's an organic software development, or we kind of figure it out and then we code what we figured out, this one actually had some difficult technical issues. And so I needed to figure those issues out through writing prototypes, through writing tests. These are the actual CAD files that Patterns sent to North Sales so that the robots could lay down the carbon fiber really precisely. So like, how could I bring this file into what I'm doing, and how can I read that data so that I can produce these projections? This is that technical test. And it's nothing visual to look at, in my opinion, at all, but it's a demonstration that it can work. So loading in that CAD file and then applying these video textures to them. And then the second technical thing to solve there was a really tricky projection mapping. Whoops. So like, how, given this really constrained space, how can we get like maximum coverage on the interior of this pavilion? And these diagrams represent our process of doing that. And in the end, in order to get everything to form and conform nicely onto the surface of the pavilion, this is the kind of distortion that needed to happen in order to do that. And you can see here there's two layers on, there's like radiating out of the different corners. And each one has a different point in the video playing through it. So it's sometimes one layer dominates and then it shifts to the other. As we go from clips from night to day, we have this other kind of transition. Okay. That is the textile room. The last piece I want to show is, it hasn't been installed yet. It's brand new. It's called A Mathematical Theory of Communication, in a nod to Claude Shannon's text of the same name, which later became The Mathematical Theory of Communication. This is the site. It's a Clark Pelly building at the University of Austin campus, and it is the Bill and Melinda Gates Computer Science Complex. And here are some images of the building. This is the large interior, very open with the stairwells. It's a very warm building, a lot of structure in the wood. The building houses two Sol LeWitt murals. Sol LeWitt is a hero idol of mine. These are my very poor snapshots of his murals, but here's one, and here's the other. And then it also houses a Sol LeWitt sculpture. And then this is my site to work with inside the building. These walls that are interior spaces for the administrative suite, and then the interior wall for the academic suite. So they're two spaces that are separated by the atrium and mirror each other. So this is the process. This is how we got from the beginning to the end, cutting out a lot in between. This was my first idea for the project. It was to actually take imagery from the building and to deal with it in terms of its component elements. This is a crop, so it shows what it actually looks like at scale. So just dealing with the RGB components and then overlaying those in order to create the larger piece. This was another image on the same line. This was the second idea, which was similar to those discs that were etched we looked at before. And here, we're taking an image that's been constructed and then pulling it apart. Being in a computer science building, I had a day where I met with a lot of the different faculty, saw the research they were doing. Computer vision is an interest of mine as well as an interest of theirs. And so the piece largely became about this idea of using computer vision techniques and algorithms and sorting through data as a metaphor for the research in the building. Here's removing perspective and doing an orthographic view, which is more diagrammatic, rather than simulating a three-dimensional space. And this was the last idea, a very different approach. And you can see related to some of the experiments we looked at before as well. So from there, we selected a direction, and then this was the direction selected, and then different groups within that. At the time I was doing this, each of these directions looked infinitely different from one another. Today, as I was going through the slides, they all look pretty similar. But this was the first direction. This was the second direction, second option, option B, using some different source material. Basically, the data that's fed into the program. This was direction C, where basically it's being looked at from the opposite direction. This was the next direction. And then the last direction was, again, this orthographic view. So it's a constrained or a tight grouping based on what was decided from the first phase. And then so this is where we ended up with in June. That I'd been working on this for 143 days. We have now 4 million lines. We have over 6 billion pixels. All that work came down to 2 images. And this is a rendering. It hasn't been printed yet. It's not on the wall yet. But it's a Photoshop hack job of what it will look like. This is what it looks like in isolation. And what's really important for me about this piece is how it looks at different scales. So this is what it looks like standing about 12 feet away or so from the mural. It shifts a great deal. This is what it looks like standing closer, but this is 1-to-1. And then this is for the other wall. And one thing we talked about earlier in the talk was this idea of generating and editing. And this project largely went through that cycle many, many times. I think, I actually said before how many files, but thousands or 10,000s of files. This is what the 2 pieces look like together. And then I just really quickly wanted to show you an example of that software. So unlike a lot of the earlier work, this work can't happen in real time. It can't happen 60 frames a second or 30 frames a second. You'll see how fast it runs because of all the sorting and the quantity of data being used. So this project was largely about writing code to produce images, looking at those for a long time, tuning them, making tweaks and adjustments, running it again, producing many variations, tweaking, coming back to it a few weeks later and looking at it with fresh eyes. An extensive process. And these are examples of the kind of images that are being produced that are being evaluated. And this was from the final set. Okay. The last topic of the day is a shorter topic than some other topics, and it's my teaching and my ideas about teaching. And what I'm going to talk about is relevant to foundation studies. It's relevant to the first year or second year of university study. And so we're going to start with this Marshall McLuhan aphorism, which is we shape our tools and thereafter our tools shape us. That's something I believe in. And what I'm interested in is not learning to use software, not the vocation or the practical, directly practical application, but learning to create software. I'm of the opinion that when you learn to use a specific piece of software, it closes down opportunities. Computation as a medium is large and it's not boundless, but it's pregnant with opportunity. When you use a specific piece of software, it's a narrow slice of what computation can do. And when you learn how to use a piece of software, you're putting your mind in the frame of what that specific piece of software does. When you learn to create software, it opens opportunity. And to that end, since 2001, we've been making this project processing. This idea of teaching how to think about making software, what's behind these programs that we are all so fluent in and use, as a way of opening up the design space. And I want to show a few examples. So So here you can see, this was part of an exhibition that's currently up at the Max Center in Vienna, where we are presenting the code side by side with its output. And again, this is highly related to what we're doing in the workshop today in the next couple of days. So, yeah, the instructions and then what's produced by the instructions. For time, I'm going to cut this right now. It's on view in Vienna if you'd like to see the full thing. Or I'm really happy to share it with you all. It's totally open source software as well. So to the end of teaching, we've been thinking about teaching and then documenting that teaching, experimenting in the classroom and then documenting those experiments through a series of publications. So I think this slide, more than any other slide in the presentation, is in a way my life's work. It represents more energy and effort than anything I've ever done. But this is how we introduce this within the university. And it's the same things that you introduce in a CS 101 class, but in a different order with different priorities and privileges. You can see we're talking about drawing, color, interactivity in the left, and then we move on and we deal with loading in different media, working with text, and image, and 3D drawing. And then we start getting into things which are more the beginning of a computer science class, talking about functions and object-oriented programming. And then we start to put everything together and start dealing with multiplicity and start thinking about simulation and data loading and visualization and interface techniques. And so this text is really built to be about a semester long. We've used it at the undergrad and grad level. And I think for me what's interesting about this book is that it teaches ideas of code and computation and programming in a way that's very different from prior text. It's about 1/3 code, 1/3 prose, and 1/3 diagrams, which you can see are represented in this page. Another approach, which is more for the casual audience, it's for workshoppers, it's for middle schoolers, is this largely more informal book, where you can see we're talking about the same ideas, we're compressing a lot, just talking about the real basics rather than going in more depth. But again, we start by talking about drawing. We introduce the idea of variables, loading in media, programming for motion. And then I'm going to sort of end the lecture, instead of not looking at my work, but looking at other people's work across the fields. This book, Form and Code, and notice the subtitle there, and Design, Art, and Architecture, is about taking what we see as common practices and common ideas and flattening them and not separating them between the different departments and areas and presenting those. And again, this is really largely written as an introduction, and we simplify in order to make it approachable. But I think the most important thing about this book is that it's meant to allow the reader to answer these three questions. How has software affected the visual arts? What's more important is what is the potential for software within the visual arts? And then what I think is the most important is, as a designer or artist, why would I personally want to or need to write software? In a way, this book comes before the instructional material. Once you already know how to have the motivation, a book about programming is very useful. This book is sort of leading people into why would you even think about doing this? It's something that's difficult and takes years to do, but it's something with a lot of interesting opportunities. So repeat. Here's an example from Jennifer Steinkamp. This piece is animated, it's in motion. It's a large-scale projection. This is a website from 1997 by Jody. Another example from that. This is a piece by the very many, Mark Forns, from 2008 called Aperiodic Vertebrae version 2. You can see here the files, you can see here the joints, and here you can see the finished piece. This one doesn't, as far as I know, doesn't use computation or software sort of directly in terms of writing code, but it's the idea that I think is important. This is an example of recursion, and this is the Serpentine Pavilion from 2002 by Toyo Ito. The idea of transformation. Here we have Zaha Hadid's Cirrus, which is in Cincinnati. This example of taking a line and then transforming it over time to produce this object, this bench seating area. This is an example of transcoding by Alex Dragulescu, where he takes malware, for example, a computer virus, and takes the instructions or the text of that computer virus and translates it into a visual form, an encoding. This is a piece called The Last Clock, which is this idea of slit scanning that we looked at briefly before. In terms of this idea of parameterization, like instead of making one thing, you make a system. The thing can be used to make multiples. So here we have the Fair Tower by Morphosis. I think the second from the left, this is, for me, the most interesting diagram, and it shows the different panels used in the building. So how do you make the panels similar rather than all being unique to cut down on the construction tooling? Here's two paintings by Manfred Moore that deal with hypercube geometry. This is by Shop. It's the Rector Street Bridge. Here we're using transformation to produce variation, both, I think, for visual interest and also for transparency and visibility. Within the area of visualization, this is a piece by Ben Fry, which is visualizing genome data. This is from 2003. Here's a piece by Aaron Koblin called Flight Patterns. This was started in 2005, and then this is a version from 2009, where we're actually looking at the air traffic over the Southwest. This is a piece by So Limited, which is a performance piece. And this piece is a live performance that happens during the presidential debates, where it analyzes words, analyzes phrases, and then basically does visualization of how the John McCain and Barack Obama were using language as a part of the debates. And then our last topic is simulation. This is a piece by Moss Architects. Here they used processing to produce simulations that then became the instructions for producing a physical object. This was for the Buckminster Fuller show that was the Whitney. It's from 2008. This is a piece by Andy Lomas called Aggregation 4 from 2005. And this is a simulation, but it's inspired by coral growth. And then here we have Gramazio and Kohler, the resolution wall from 2007, using genetic algorithms to produce these different block structures that were then fabricated and built. So I have a neat and tidy conclusion for the lecture that I'm going to go through. So in the 21st century, I believe that all artists and designers should have experience programming their own software. Nearly everyone uses software as in the production of their work, even in the most traditional fields. Software is certainly a powerful tool, but when a person doesn't understand how software works at a deeper level than using a program to retouch a photo or build a 3D model by pointing and clicking, that person's engaging in software in a shallow way rather than a deeper way. So remember our McLuhan aphorism, we shape our tools and thereafter our tools shape us. So if a person can't shape a new tool, that person's shaped and molded by another person's idea about what software is or can be, and about what their own work is and can be. So thanks very much for your attention. That's the end.